Gliese 710, the star that's headed our way. Do you know what's coming our way? It's Gliese 710, a star that's headed straight towards us. And we're not talking about a near miss. It's actually going to pass by our solar system. But don't worry, it's not going to hit us. In fact, it's going to pass by at a distance of about 16,000 astronomical units, which is about 240 trillion kilometers away. That's still pretty close in astronomical terms. For reference, the solar system is 1,921 astronomical units in diameter, so it will still be far away from us. That's right, folks. It's like a real-life version of the movie Armageddon, only instead of Bruce Willis and a team of oil drillers, we're relying on astrophysicists to save the day. Just kidding, but it would be an amazing view to witness. Let's see why. So grab your telescopes and popcorn, because we're in for a wild ride. Gliese 710. So what do we know about this star? Well, Gliese 710 is a small, cool red dwarf star located in the constellation Serpens, about 64 light-years away from Earth. While 64 light-years may sound like a long distance, it's actually relatively close in astronomical terms. In fact, it's one of the closest known stars on a trajectory to pass relatively close to our solar system. The star itself is about half the size of our Sun, and it's much cooler, with a surface temperature of around 3,500 degrees Celsius, compared to the Sun's 5,500 degrees Celsius. Despite its small size, Gliese 710 is still a relatively active star, with regular flares and eruptions of material from its surface. Impact on solar system. At its closest approach, Gliese 710 will be about 16,000 astronomical units away from our solar system, which is about 240 trillion kilometers. While that still may sound like a vast distance, it's close enough to have some interesting effects on our solar system. The biggest impact that Gliese 710 is expected to have on our solar system is on the comets and other icy objects in the Oort cloud, a region of space that's filled with comets and other icy objects that orbit the Sun at distances of up to 100,000 astronomical units. The Oort cloud is thought to be the source of most of the long-period comets that enter the inner solar system. Long-period comets have slightly elliptical orbits that take them far from the Sun, and they're thought to originate in the Oort cloud. When they get close enough to the Sun, they heat up and release gas and dust, creating a coma and a tail that can be seen from Earth. Scattered disk objects, on the other hand, have more circular orbits that are tilted relative to the plane of the solar system, and they are thought to have been ejected from the Kuiper belt into the Oort cloud. The existence of the Oort cloud has not been directly observed, and its properties are inferred from the behavior of comets and other objects in the outer solar system. Its existence is supported by the fact that many comets have highly elliptical orbits that cannot be explained by the gravitational influence of the known planets alone. When Gliese 710 passes through the Oort cloud, it's expected to perturb the orbits of some of these icy objects. Some will be sent on a trajectory towards the inner solar system, potentially leading to spectacular meteor showers. Discovery of Gliese 710's approach. The first indication that Gliese 710 was on a trajectory to pass relatively close to our solar system came from observations of its motion through space. Gliese 710 is what is known as a high proper motion star, meaning it moves relatively quickly across the sky. Its high proper motion was first measured in 1995 by a team of astronomers led by Ellen Goncharov. The proper motion of Gliese 710 is about 1.47 arcseconds per year in right ascension and minus 0.62 arcseconds per year in declination. This means that the star moves by 1.47 arcseconds towards the east and by 0.62 arcseconds towards the south every year, as seen from Earth. This proper motion is relatively high compared to most stars in the sky, but it's not exceptional. The motion is due to the star's actual movement through space relative to the Sun. Gliese 710 is part of the local interstellar cloud, which is a region of space that contains several nearby stars and is moving through the Milky Way galaxy at a speed of about 26 kilometers per second. By studying the star's motion and trajectory, astronomers were able to determine that it's on a path that will bring it relatively close to our solar system in about 1.35 million years. Since then, the star has been the subject of much study and speculation, with astronomers eager to learn more about its properties and its impact on our solar system. One of the challenges in studying Gliese 710 is its distance from Earth. While it's relatively close in astronomical terms, it's still too far away to study in detail with current telescopes. However, astronomers have been able to learn a lot about the star through a technique called spectroscopy. Spectroscopy is a technique that involves studying the light emitted by a star or other celestial objects. By analyzing the spectrum of the light, astronomers can determine the chemical composition of the star, as well as its temperature, size, and other properties. Exoplanet Gliese 710b. Now, one might wonder, does Gliese 710b have a planet? If yes, what would happen to it? The answer is yes. Gliese 710b is a confirmed exoplanet in the orbit of its star. Gliese 710b is classified as a gas giant, with a mass similar to that of Jupiter. It has an orbital period of around 10.2 days and orbits its host star at a distance of just 0.08 astronomical units (AU), which is much closer than Mercury's orbit around the Sun. Because of its close proximity to its host star, Gliese 710b is classified as a hot Jupiter, a type of exoplanet that is massive and gaseous like Jupiter, but orbits very close to its star, causing it to have a very high surface temperature. Gliese 710b is an important target for exoplanet research, as it provides an opportunity to study the atmosphere and composition of a gas giant planet in close proximity to its host star. However, the close orbit and high temperature of Gliese 710b also make it an unlikely candidate for supporting life as we know it. If Gliese 710 were to pass through or near the Oort cloud, it could potentially perturb the orbits of the objects within it, including comets and other icy bodies. If Gliese 710b were on an orbit that intersected with the Oort cloud, it could potentially be ejected from its orbit or have its trajectory altered by the gravitational interactions with the objects in the cloud. That would mean that the star would lose its planet and be lonely, or it might catch one of the objects in the Oort cloud and make it its own. Who knows? Alternatively, if Gliese 710b was far enough from the Oort cloud, it might not be affected at all. It's worth noting that the Oort cloud is extremely vast and diffuse, and its objects are widely spaced apart from each other, so the chances of a collision between Gliese 710 and any object in the cloud are very low. However, even a small perturbation of an object's orbit can have a significant effect over long periods of time, so the exact outcome of any interaction between Gliese 710 and the Oort cloud is difficult to predict with certainty. Could Gliese 710 collide with the Sun? What would happen if Gliese 710 collided with the Sun? A collision between two stars is an extremely rare event due to the vast distances between them. But let's play with scenarios a little. The collision would likely occur at very high speeds, causing the two stars to merge and release an enormous amount of energy. This would result in a powerful explosion called a supernova, which is one of the most energetic events in the universe. Supernovae release huge amounts of radiation in the form of gamma rays and X-rays, as well as a blast wave of particles and high-energy radiation. The energy released would be many times greater than the energy output of the Sun over its entire lifetime. The shock wave from the explosion would travel outwards from the point of impact, destroying everything in its path. If our planet Earth were to survive the initial supernova explosion, it would be subjected to extreme temperatures and radiation, which would strip away much of the atmosphere and likely sterilize the planet. The intense radiation would also cause genetic mutations and damage to living organisms, making it extremely difficult for life to survive. So mark your calendars for about 1.35 million years from now, because that's when Gliese 710 is expected to make its closest approach to our solar system. And who knows, maybe by then we'll have developed the technology to travel to other star systems and meet our cosmic neighbors. It's important to note that Gliese 710 is not actually on a collision course with the solar system, and any hypothetical scenarios involving its approach to the Oort cloud are purely speculative. Nonetheless, the study of stars like Gliese 710 helps us to better understand the nature and diversity of the universe we inhabit. Thanks for watching, and don't forget to subscribe for more fun and fascinating videos about the universe.